People can arrive at the stars, even ones at tremendous distances, if their boat can accomplish a speed near the speed of light. Time expansion expands the life expectancy, at any rate, as far as Earth's schedule. Nonetheless, society may have changed radically when the travelers get back. Designers still cannot seem to construct a drive gadget that verges on achieving the necessary velocities, and analysts do not have a clue what sort of machine would offer the best execution. A few motors are being examined, including particle motors and impetus utilizing thermal power. With their proficiency and gradual speed increase, ion motors have a few benefits. Achieving high velocities should be cultivated slowly. Something else, the absolute powers related to fast speed increases would pulverize the travelers. Speed increase extents are regularly estimated in units of g. The speed increase experienced by an item on the outside of Earth, 1g, is 32 feet per second squared, 9.8 meters per second squared. The speed of a dropped object increments at a pace of 32 feet per second, 9.8 meters per second, for consistently it falls, without different powers, for example, air opposition. This equivalents the natural pull of gravity that everybody feels. A speed increase of 2g is twice as high, and thus, an individual would feel twice as hefty. Another of Einstein's revelations is that the impacts of speed increase, the push in the back as a vehicle speeds up, for instance, are indistinct from gravity. This implies that a boat speeding up to 1g would appear to have ordinary gravity, in which dropped articles would fall towards the floor, or, all the more precisely, rearward of the boat, at a pace of 32 feet per second squared, 9.8 meters per second squared. Marginally higher speed increases are bearable, yet awkward. Space transport space explorers, for instance, experience brief scenes of around 3 or 4g. Individuals black out at around 12g, and surprisingly higher speed increases can smash and execute. A constant, delicate speed increase of 1g would be ideal from a traveler's viewpoint. The boat would require a significant period to find a good pace. However, it would likewise give an agreeable climate all the while. One of the troubles with this situation is fuel. Dependable speed increases utilize an inordinate measure of fuel, which should be conveyed at dispatch time, except if fuel can be recharged in flight. A huge mass of fuel makes dispatches restrictively costly, just as perilous. Conveying much fuel during the excursion likewise presents serious dangers of fire and blast. In space, even minor setbacks can be lethal. To limit the mass while influencing delayed speed increases, the fuel should be wealthy in energy, but not massive. A few choices are conceivable. An ideal alternative would permit the transformation of all fuel into energy. This choice is conceivable under specific circumpositions, as discussed in part beneath, named motors that use antimatter. Another choice that is right now plausible is energy from an iota's core. Atomic responses like parting, in which core parts and combination, in which cores join, yield much energy. Parting is the less complex of the two responses to control and has been utilized in atomic re-entertainers to create power for customers and move certain boats and submarines. Space offices have effectively joined atomic force into the energy supply and tests that should travel significant distances from the Sun. For example, tests that visit the outer planets. Tests that do not wander a long way from the Sun will, in general, utilize sunlight-based energy, since they can catch enough of the Sun's energy to work. Nevertheless, atomic force gives analytical instruments and another electrical device, instead of driving the vehicle through space. NASA, as of late, started a program called Project Prometheus, pointed towards investigating atomic impetus. In Greek folklore, Prometheus was a titan who took fire from the divine beings and offered it to individuals. On April 18, 2005, the office gave a news discharge requesting a public remark on the task. The news discharge expressed that they were assessing the possibility of building up a space atomic reactor to supply future investigation rocket with a huge expansion in installed force and shuttle drivability. Such an increment in force would empower missions to the external scopes of the close planetary system and pass just as substantially expanding the measure of science per mission. However, because of spending imperatives, contending tasks, and resistance to atomic force, all in all, NASA has not yet effectively sought after this program. One of the principal concerns is that a mishap during takeoff of an atomic-fueled rocket could bring about the arrival of risky material, like the 1986 blast of the Chernobyl atomic reactor in Ukraine. Another issue for human-maintained space apparatus is that safeguards should be introduced to shield the group from the reactor, adding to the vehicle's more significant part. Despite the wellspring of drive, a critical worry with high-velocity travel is the danger of impacts. Albeit interstellar space is almost a vacuum, it contains various particles, atoms, and more vast pieces of trash. If a boat hits a stone while cruising at 93,000 miles per second, 150,000 kilometers per second, 0.5 c, the impact is identical to a shot striking the vessel at 0.5 c. Such an impact would cause disastrous harm, regardless of whether the stone is minuscule. A rock, for instance, could go through the boat, breaking the fuselage and permitting air to get away. The potential gain is that boats might have the option to gather up interstellar material as fuel, particularly the moderately bountiful hydrogen particles. Yet future researchers and architects should prepare a system to divert bigger and possibly dangerous items. The requirement for a gigantic measure of fuel for interstellar travel can stay away if the boat somehow acquires the necessary engine as it comes. One strategy for achieving this is to gather up interstellar material. However, another chance is to utilize sun-oriented energy mainly. Electromagnetic radiation emanating from the sun has both wave and molecule perspectives. The particles, called photons, carry on as little parcels of energy that either ricochet off or assimilate when they experience objects. Photons along these lines apply pressure. One photon does not have much energy and makes just a slight pressing factor. However, the impact increments when photons are plentiful. An extra wellspring of pressing factors is the sunlight-based breeze. The external layers of the sun launch a constant flow of particles, principally protons and electrons, because the high temperature pushes them out of the sun's gravitational field. These particles proceed away from the sun at high rates, shooting past Earth at around 310 miles per second, 500 kilometers per second. When acting over multiple zones, photons and the sun-based breeze can have visual impacts. The tail of a comet, for instance, focuses away from the sun because of this crucial factor. Some innovative scientists have noticed that this critical factor may be saddled to drive a spaceship. The thought is to attach a big sail, a sunlight-based sail, to get the sun-orientated breeze and radiation. Space travelers would cruise through space like the old cruising vessels that employed the oceans. The sail should be broad to get enough wind and ought to be profoundly intelligent. Cleaned like a mirror, so that this light reflects from the surface instead of getting assimilated. Reflection moves more energy to the sail. Regardless of whether it covers an immense region, a slender sail can be produced using lightweight material, diminishing the mass at takeoff. Taking off in Earth's thick climate with such a sail would be rash. However, the sail can be sewed together in space or moved up and fitted inside a rocket and spread out in space. Sunlight-based cruising would not create a lot of speed increase. However, it would be consistent. Crashes with trash and different types would presumably happen if the sail covers a wide zone. However, openings in the sail would not be disastrous and could be fixed depending on the situation. An early form of spaceship working with a sunlight-based sail was Cosmos 1, a joint task of the Planetary Society, an association committed to space investigation, and Cosmos Studios, an organization drove by Anne Druin, creator and widow of the late cosmologist Carl Sagan, 1934 to 1996. Dispatched on June 21, 2005, joined a submarine dispatch rocket. The boat spread its sails in space. The Planetary Society depicted the objective of their task on their sun-oriented sailing webpage. Universe 1 was not proposed to go to the stars, yet, just to demonstrate that sun-based sailing was conceivable, when the shuttle had entered Earth's circle, it was to raise its elevation through sunlight-based cruising. Any quantifiable expansion in the shuttle circle would have been viewed as a triumph. Nevertheless, the rocket fizzled, and Cosmos 1 was lost. Sun-powered cruising may be sufficient to push a spaceship through the nearby planetary group. However, what might be said about interstellar space? The considerable span would, at last, deliver the constraint too little even to consider being very useful. In 1989, the physicist and sci-fi creator Robert L. Forward, 1932 to 2002, described the utilization of a laser bar to impetus. The idea is equivalent to a sun-oriented sail, except for the radiation pressure comes from a severe laser instead of the sun or another sail. The term laser represents light intensification by the animated discharge of radiation. When siphoned with energy, photons in the laser invigorate the creation of different photons of a similar frequency, radiated in a rational shape. Laser radiates do not spread close to light from sources like an electric lamp, so the energy stays moved in a piece of space over significant distances. This is ideal for a spaceship sail. Researchers on Earth have effectively ricocheted laser radiates off the Moon to measure Earth's distance, and the Moon with incredible exactness. The laser radiates bobbed off uncommon reflectors set on the Moon's surface by Apollo space explorers. By and by, laser drive is an intelligent thought. The laser could be set up in a circle around the Earth and train its pillar on the spaceship. Be that as it may, the ability to drive a spaceship interstellar distances would be colossal and past the limit of current gadgets. Sunlight-based sails, laser radiates, and the utilization of interstellar hydrogen might have the option to give the lethargic, consistent speed increase expected to arrive at the stars. Yet none of these strategies might be entirely adequate. Some other sort of motor may be essential to enhance the principal drive. On the off chance that this motor and its fuel are profoundly influential, different strategies probably will not be required. Motors that utilize antimatter is prime up-and-comers. NASA is thinking about creating antimatter motors for a human-maintained mission to Mars, and if the strategy works, maybe various excursions would be plausible. In an official statement given on April 14, 2006, NASA noted, "Most self-regarding starships in sci-fi stories use antimatter as fuel for a valid justification. It's the most intense fuel known. Antimatter is like matter, except for explicit properties. For example, electric charges are turned around. All particles have an antimatter partner, known as its antiparticle. A few particles, for example, the photon, are their antiparticle. For instance, the position has a similar mass and charge extent as an electron. However, the charge's indication is switched. Positrons are emphatically charged rather than adversely charged, similar to the electron. The terminology positron is short for positive electron. When matter and antimatter meet, they are destroyed in an eruption of energy. Matter-antimatter obliteration is a particularly abundant fuel source because the mass of the two particles gets changed into high-energy photons. This is finished transformation. 100% of the fuel is utilized, not standard for different strategies to create power, all of which leave a significant buildup that is squandered. Atomic force, for instance, changes over just 1 to 3% of the mass of the fuel into energy. There are issues with a potential matter-antimatter motor. High-energy photons are perilous, so group individuals should be protected. Putting away antimatter additionally presents trouble since any contact with the issue brings about obliteration. Antimatter should be kept with electric or attractive fields instead of customary holders. There is likewise the issue of cost. Antimatter creation happens just under high-energy investigations, like the crashes of molecule gas pedals, which are very costly to work. NASA researchers are dealing with the ideal alternatives and a novel plan. As per April 14, 2006 news discharge, past antimatter-fueled spaceship plans utilized antiprotons, which produce high-energy gamma beams when they demolish. The new plan will utilize protons, which make gamma beams with around multiple times less energy. Gerald Smith, a specialist at Positronics Research, an organization situated in Santa Fe, New Mexico, talked about the expense. A good guess to deliver the 10 milligrams of positrons required for a human Mars mission is around $250 million, utilizing innovation that is at present being worked on. Although the cost will fall as analysts figure out how to create antimatter all the more proficiently, an excursion to the stars would cost considerably more. Spacetime and wormholes. The prohibiting distances isolating the stars will, in general, hose any idealistic solutions of interstellar travel. Indeed, even the most energetically of room investigation should recognize the troubles. There is a slight possibility that the tremendous distance may demonstrate insignificant if individuals can discover accessible routes through space. One chance is a wormhole. Wormholes are burrows, associating various pieces of existence. In his overall hypothesis of relativity, Einstein imagined gravitation as a distortion of existence. Einstein's image of the universe comprised 4 measurements, 3 of room and 1 of time, known as spacetime, in which the presence of an enormous body bent or twisted the spacetime in its area. This arch, Einstein proposed, was the motivation behind why objects with mass pull in each other, rather than considering gravitation as a power acting a good ways off. Einstein envisioned it mathematically. Much proof has been found to help the overall hypothesis of relativity. Quite possibly, the most surprising of its forecasts was that the universe is extending. Indeed, even the hypothesis pioneer experienced difficulty accepting this forecast, so Einstein embedded a term in the confounded. However, astrophysicists found in any case, and Einstein confessed his mix-up. The overall hypothesis of relativity is one of the establishments of present-day material science and is utilized a considerable scope model of the universe. A few energizing articles show up in the answers for the conditions of general relativity. One article is a dark opening, an item with a gravitational field so solid that nothing, not light, can get away from it. Another article is a wormhole, which frames such a passage through spacetime as represented in the figure. This passage may be an alternate route, associating one mark of spacetime to another. In any case, regardless of whether wormholes exist, nobody knows whether they will be navigable. The conditions show that these items would be unstable. For example, if bits of issue, a residue cloud, a stone, or a space travel attempts to enter the wormhole may suddenly snap shut, with unfortunate results. In a 1989 paper, the California Institute of Technology physicists Michael Morris, Kip Thorne, and Ulvi Yurtsever portrayed a hypothetical technique for setting a wormhole open. These specialists tracked down that the addition of huge masses and electric fields could keep the tunnel clear. However, a portion of these augmentations should have odd properties. For example, applying a negative pressing factor, a vacuum. Nonetheless, different sorts of wormholes may be simpler to cross without the requirement for strange types of issues to support them. Wormholes address legitimate answers for the intricate conditions of general relativity. Yet this does not infer that they exist. The hypothesis shows their reality, yet does not need it. Astrophysicists have discovered no proof of a wormhole, albeit this does not demonstrate that they do not exist. By and by, if wormholes exist, a portion of their properties recommend upsetting mysteries. For example, wormholes are alternate routes in space and on schedule, so a wormhole may go about as a time machine on the off chance that one exists. Time travel is energized, yet summons conundrums like the chance of meeting oneself or coincidentally causing a circumstance in which one's folks neglect to recreate. These problems appear to be inconceivable, so time travel would likewise have all the earmarks of being incomprehensible. Assuming that this is the case, maybe wormholes have no premise as a general rule. Individuals have investigated just a tiny corner of the universe, which lives nearby, a little star with 8 planets. Astrophysicists and physicists have taken in a great deal with their telescopes and their inventive hypotheses. For example, Einstein's overall hypothesis of relativity. Yet there is entirely left to be found. Nobody realizes what awaits future interstellar pioneers as they meander the vast distances between the stars. They may discover numerous odd articles, perhaps much more in common than wormholes. Alternative routes through space and quicker-than-light travel frequently structure the foundation of intriguing sci-fi stories. These gadgets make it feasible for creators to utilize plots, including galactic domains and fighting groups. Yet most of these gadgets abuse the laws of physical science or grant inconsistencies that are incredibly improbable to exist in nature. There is no motivation to expect that presently acknowledged logical speculations would stand everlastingly. Yet, the easygoing excusal of the laws of physical science, as they are currently perceived, strains conviction. Other progressed ideas of the interstellar investigation will keep the laws of physical science all the more intently. Indeed, even with this imperative, many energizing advancements are possible. One idea is the quicker-than-light movement of theoretical particles called tachyons. The terminology tachyon derives from the Greek word tachys, signifying quick. As indicated by Einstein's hypothesis, no particle with mass can at any point be sped up to or past c, the speed of light in a vacuum. Just photons, which have no rest mass, can arrive at this speed. As a molecule or item with mass, methodologies c, its mass appears to expand, making subsequent speed increase much more troublesome. At c, the mass would get boundless, which is unimaginable. Hence, no particle with mass can arrive at a speed equivalent to c. Be that as it may, there is perhaps another chance. Assume a molecule has consistently been going past c. Nobody could protest an outlandish increment of mass with speed increase because a tachyon was not sped up to or past c. It was conceived surpassing this speed. Tachyons could never back off to c, since this would involve endless mass. The speed of light would be the base instead of the most extreme for tachyon speed. Nobody has, at any point, noticed a tachyon. On the off chance that they exist, proof of these particles may require another and completely extraordinary arrangement of instruments. Something else, the quicker-than-light items, may stay imperceptible. Tachyons may help correspond and other transmission gadgets. Yet it is not apparent how they may be utilized. Some gadget or instruments should associate with it in one way or another to utilize an item. The natural eye, for instance, retains light, which inspires a chain of exercises in the cerebrum that makes visible insight. Some sort of finder or transmitter would be fundamental in any tachyon gadget. By and by, nobody is sure how an instrument could collaborate with a tachyon without momentarily bringing its speed beneath the speed of light. Also, for a tachyon, no speed beneath c is allowed. Another high-level idea is teleportation. Teleportation is the transportation or move of the issue across space with no straightforward medium. On the TV arrangement Star Trek, individuals and lifeless things are frequently radiated from a starship to a planet and back again with unique teleportation gadgets. The item to be radiated vanishes at one site and returns in the ideal area. Albeit this cycle appears to be profoundly unrealistic, a comparative method known as quantum teleportation is inside the domain of the laws of physical science. Quantum teleportation utilizes standards of quantum mechanics, like the capacity of an item to exist in different states simultaneously, to make copies of the condition of little articles like photons or molecules. The particles appear to hop across space. For instance, FoxNews.com provided details regarding January 26, 2009, that the University of Maryland scientist Christopher Monroe and his associates prevailing about transporting a quantum state starting with one particle and then onto the next across a distance of 3.3 feet, 1 meter. Such accomplishments require unbelievable ability and have just been fruitful for small particles and brief distances. Reformist thoughts like teleportation, laser sails, and antimatter motors are just in their beginning phases of improvement. Similarly, as with every groundbreaking thought, they could conceivably work. In any case, research at the boondocks of Room and stargazing are examining choices to allow people in the future of pioneers to arrive at the stars. Accomplishing practical travel for interstellar travel would fundamentally upgrade the current comprehension of the universe and humanity's place inside it. Discovery of gravitational waves. The places of light in the night sky prodded inquisitive onlookers to build up the study of cosmology. As researchers contemplated the light of far-off stars or the light reflected from different planets in the nearby planetary group, their comprehension of the universe multiplied. Apparent light is just one type of electromagnetic wave, otherwise called electromagnetic radiation. Light involves a tiny segment of the electromagnetic range. When astrophysicists created instruments to distinguish different range pieces, they opened other favorable windows into the universe, like radio waves. Extra windows would likewise incredibly profit stargazing. This is the reason astrophysicists are keen on a kind of wave called a gravitational wave. Gravitational waves are engine-during aggravations set up by specific movements of enormous particles. Researchers have not yet demonstrated the presence of these waves because nobody has straightforwardly noticed one. The hypothesis of general relativity, one of the establishments of current physical science, predicts this wonder, and cautious estimations support this forecast, albeit by implication. By the impacts of the emanation of gravitational waves have on a specific star framework. Direct perception of these tiny and hard-to-recognize waves would definitely demonstrate their reality. Instruments equipped for noticing gravitational waves would likewise empower specialists to direct vital trails of general relativity and give much data on the movement and nature of huge particles in the universe. Gravitational waves offer a terrific method to look into deep space. Endeavors to notice gravitational waves, just as the possibilities for progress, are talked about. Waves are engineering aggravations. Consider what happens when somebody tosses a stone in a lake, for instance. At where the stone enters the surface, water is momentarily uprooted. This water shakes its neighbors. Since water is almost incomprehensible, it can only with significant effort be pressed into a more modest volume. The energy gets communicated down the line instead of immediately ingested. Neighbors jar neighbors, etc. Therefore, the underlying upsetting influence spreads every which way from the source, and the wave clears across the outside of the lake. In a wave, the unsettling influence voyages or spreads, not the material in which the waves travel. A wave in a lake, for instance, is an engineering unsettling influence of the water. The energy of the movement is the thing that moves outward from the birthplace. Although water particles taking part in the wave go here and there and shake the nigh-exhausting atoms, their commitment is confined. They do not go alongside the wave. Another model is the wave that engenders in jammed arenas as fans in back-to-back areas stand up and afterward plunk down once more. The wave, for this situation, is the all-over movement of the fans, none of whom change seats simultaneously. The material where the waves proliferate is known as the medium. For a wave in a lake, the mechanism of the wave is water. Water conveys the wave. Fans in the arena are the transportation of the waves that move through the group. Fundamental properties of waves incorporate abundancy and frequency, as shown in the figure which shows the vibrating string. The adequacy of the wave is the most excellent removal. Frequency is the distance between two relating focuses in the wave cycle. For example, if the separation starting with one peak and then onto the next. Recurrence shows the number of wave patterns each second, generally depicted in units of hertz, or cycles each second. Named for the German physicist Heinrich Hertz, who examined electromagnetic waves. Frequency and recurrence are connected. The higher the recurrence, the more drawn out the frequency, and the other way around. The result of frequency and recurrence is the speed of the wave. For the most part, attributes like the median, like its compressibility, and protection from movement decide how quickly a wave moves. The energy of a wave relies upon its abundance and recurrence. A few waves lose energy as erosion diminishes the development, making the waves subside sooner or later. Another significant factor influencing energy is distance. A spherical wave radiates from a source every which way. For example, the sound waves made by applauding, or light coming from a light. Round waves, by and large, submit to the converse square law. Their solidarity diminishes with the square of the source's distance. This is because the energy per unit region diminishes as a circular wave moves outward. The round surface of the wave increments as it grows. However, the energy remains something very similar, so there is less energy at each point. Think about daylight, for instance. And Earth-sized planets circling multiple times further from the Sun than Earth would get multiple times less sun-based energy, since 4 is the square of 2. A fascinating inquiry can be raised about waves in space, like electromagnetic waves and theoretical gravitational waves. Space is a vacuum with meagerly appropriated material like hydrogen molecules and dust storms. On the off chance that a wave travels through space, what precisely is waving? Electromagnetic waves emerging during the 1960s when the Scottish physicist James Clerk Maxwell anticipated such waves and speculated. The light is an electromagnetic wave. After Hertz delivered and distinguished radio waves in 1888, affirming the presence of electromagnetic waves, researchers considered what may be conveying those waves. One proposition was that an inescapable material called the ether, or luminiferous light-conveying ether, was the median. The speculative material filled the universe, and, to fill its need, it needed to have some particular properties. The more grounded a medium's protection from a wave's movement, the quicker the wave can go through the medium, since the unsettling influence moves from one highlight to another all the more rapidly. Since light and other electromagnetic radiation are so quick, the ether must be profoundly inflexible to sort this sort of aggravation. By and by, the ether couldn't in any way, shape, or form influence matter. Else, it would moderate the movement of planets in their cycles, making them fall into the sun. Researchers looking for indications of a luminiferous ether could discover no proof that it existed. They, at last, surrendered, particularly after the German-American physicist Albert Einstein, presented his specific hypothesis of relativity in 1905, which does not need such an ether. Physicists reasoned that electromagnetic waves could engender space. Electromagnetic waves comprise fluctuating electric and attractive fields. Maxwell suggested that aggravation in these fields can proliferate, fanning out from the beginning at the speed of light in a vacuum. Precise movements of electric charges start these unsettling influences. For instance, the speed increase of a charge produces electromagnetic waves. So does the following of an electron into a lower, less lively circle in a particle. Albeit electromagnetic radiation has numerous waves of waves. For instance, covering light pillars can meddle, showing light and dim groups relating to the addition or deduction of the waves. Einstein proposed an option in 1905, light compromises of particles called photons. The year 1905, in which Einstein distributed a few crucial revelations, is regularly alluded to as Einstein's Annus Mirabilis, which is Latin for the term of marvels. Despite the contrast among waves and particles, the two depictions of light are legitimate, a wave-molecule duality component. Gravitational radiation, or waves, can likewise proliferate through space. The waves are related to aggravations in gravitational fields, like the electric and attractive field changes that involve electromagnetic waves. In some cases, gravitational waves are alluded to as gravity. This can make disarray since physicists additionally utilize the term gravity wave to portray something different. In liquid physical science, a gravity wave is a wave wherein gravity acts to counter or re-establish the aggravation, similar to a sea wave, in which gravity pulls at the rising peak and pulls it down once more. The conversation in this section alludes to just gravitational waves. Waves in the fabric of space. Einstein distributed the overall hypothesis of relativity in 1916, following quite a while of work. The hypothesis utilizes confounded numerical conditions to portray the power of gravitation as an arch of space-time, comprising of three components of room and one element of time. This hypothesis emerged to some degree from Einstein's endeavors to sum up his specific hypothesis of relativity, which applies just to states of steady speed, not speed increase, for example, that of an item falling in a gravitational field. In Einstein's view, space-time calculation was a more exact and rich portrayal of gravitation than the idea of power acting a ways off. General relativity predicts that unsettling gravitational influences swell through space-time at the speed of light. Utilizing a flexible elastic sheet as a space-time model, a monstrous item is positioned on the sheet will cause sadness. Bowing the texture nearby and making more modest articles move toward it. This activity addresses gravitation. Presently envision what might occur if the weighty article weaved all over. This movement would make waves or waves through the sheet. These waves are gravitational waves made by the movement of a monstrous article. Any item or arrangement of articles having mass makes gravitational waves when it changes speed or the plan of its segments. These progressions include speed increase and abrupt development or change in speed of the article or its segments. This is like a charged molecule discharging electromagnetic waves when it encounters a speed increase. The emanation of gravitational waves is confounded by the guideline known as Newton's third law, that each activity responds, each unexpected development of a mass is by and large joined by a contrary development, which will, in general, create waves that drop each other. Since the two developments are not in a similar spot, the two masses are isolated by some distance. The waves are somewhat extraordinary, so they do not drop through and through. Gravitational waves going through a territory would cause an exchanging pressure and stretch of space-time. This swaying would shift the distance between a bunch of items. For instance,